Yeah, hello class. Hope we are feeling fine.
Yes.
Now today we have come into the next topic called the inequalities and regions. That's topic, who remember that? Topic 5. Topic 5?
Yes.
Yeah, topic 4 we dealt with a lot of, I think you remember what we dealt with?
Yes, teacher.
That was?
Numerical concept.
And we dealt with indices and logarithms. It was so long ago. Now I wanted to first ask you to give you a small math riddle here, and thinking that it's a good brain teaser to help you think, wow. Now listen, and I will see somebody will answer. Yesterday I checked my 12 eggs, and there were 8 remaining. I broke 2, fried 2, and ate 2. How many remained on my tray?
6.
6 eggs remained. How are they 6?
That you got and broke and fried and ate and the same.
This is the same thing.
Yes.
Did you come into my head? No. You already knew it. Wonderful. You are very, very great. You are very, very great. Are you great?
Yes.
You are very, very great. I hope you always wake up and mention great things about yourself. I'm bright. I'm the best. I'll succeed. Did you do so? Start doing so. Now today, let's talk about inequalities and regions. That's topic 5. Inequalities and regions. Inequalities and regions. Now you notice that math, there are some people who claim that if you cut their hand with a knife, that if you like I can also claim that if you cut me with a knife and you observe my blood in a microscope, you'll find their values solving equations and the values of x. Is it true? if math can, they claim that math is in the blood, not so? Can math enter your blood? Not really. Okay, but I want you to master the math to the letter, because math is very, very simple. Okay, now under inequalities and regions, we shall discuss some subtopics here. The first subtopic we shall discuss meaning of the inequality, Then we shall also visit solving inequalities. Yeah. Then representing inequalities on the number line, representing inequalities on the number line. Then and solution sets. That means we shall see the number line and solution sets. Then we shall also visit now solving inequalities in 2 unknowns, x and y. Inequalities in 2 unknowns, that's x and y, which we simply call regions, that we shall shade the regions, unwanted and wanted regions. Then lastly we shall forming inequalities from word problems. See, from word problems. Now I request that you pay maximum attention. Maximum attention. Yeah. Yeah, maximum attention. Let us start with what does that word inequality mean. We shall keep time today. So be very, very attentive. Subtopic 1, meaning of inequalities. What does that mean? I hope you remember how we dealt with the concept of algebra 1 and we looked at equations. Do you recall that? And we said an equation is an expression having equal signs. Did we say that? That the word equation means that expression having equal signs, like this is equal to 6, this is an equation, an expression having equal signs. Now, there is where we change those equal signs to some other symbols. You see those? See? Now, when the expression has a less, this is less, pointing this way. This is greater. This is, it is pointing this way, less than or equal to. Then this one is greater than or equal to. Now, expressions having these are called inequalities. So we can keep that an inequality is an algebraic expression having an algebraic, the spelling, that means it is an expression of algebra, an algebraic expression having either this, comma, this, that, or that. E.g., who can give us some examples now with reference to what we've done here? E.g., yes, let me pick Penitency. 5 is greater than 3. So we read this is 5 is greater than what? Greater than 3. Can you give us those ones having some unknowns? Your hand was up, yes?
X is less than 3.
Less than 3. That's right. X is less than what? 3. That's right. You want to add more? I think people, you can add more later on your own also. What if somebody said x minus 4 is greater or equal to 6? Isn't that true? Yeah, that's also true. Now, let us right away go to solving inequalities. See? Solving inequalities. I hope you've noticed those subheadings. Me, I will have to follow them. So, solving inequalities. Now we have a few rules here, like ordinarily we can solve equations. The same way we solve equations is the same way we solve inequalities, but keeping note of a few rules. See, keeping note of a few, but the method remains the what? So, the same. So, it remains exactly the same. So, solving what? Inequalities. Let us look at those rules. We are saying the method is the same, but there are a few rules. See, rules of solving what? See, solving what? Inequalities, not so? Yeah. See, now you must listen. You must really make them to your fingertips. Now, rule 1 is that dividing, see, or what? Multiplying an inequality by a negative reverses the sign of the inequality. There you are. What does it mean? See, e.g. negative 3x is less than a hot 6. So if I try to divide by negative 3, negative what? 3. So since I use the negative in the division, the sign, in fact, at this same stage of division, we change the hot. So x will be greater than what? Negative 2. You believe that?
Yes.
So, yeah. For in part B, we said you can also multiply. Like if you had x is greater than 4, then you try to introduce a negative onto them. You see, onto what? You are trying to multiply by a negative. So you will put in a negative and the sign will what? The negative will affect this and then the sign will change. So now, okay, now we can pick on rule 2 that rule 2. What does that rule 2 say? That interchanging parts of the inequality reverses the sign. Did you hear that? Interchanging parts of the inequality reverses the what? Yes, yeah. Interchanging parts of the inequality reverses what? Reverses the sign. How? E.g., if you have x is greater than 2, can be said to be now if you bring the 2 this way and x goes there, 2 is less than what? That's why saying what is true here? Which sign could we put here? Negative 1 is what with the negative 2? Who is greater than the other? That. So if you wrote negative 2 will now be what? That's exactly. You see? Those are the two key important rules. Now, let us start to solve ini. We've said the same methods of solving inequalities remain the same. Solving inequalities. And to your attention, I will do roughly like 2 numbers. Then you'll help me. Will you? 1 per person. Okay. Solving inequalities examples. And did I say I will do only how many?
2.
That's exactly. So, solve each. Yeah? It does not mean I will only do 2, I will add more. So that's 10 minus 3x less than 4 into x minus 1. That's A. Now, how would we handle this if it was ordinary equation? Never put equal signs here. See? So I will maintain the same principles, then open the other side first, That's 4x minus 4. Then I collect like terms. I'll first take this the other side, then by adding, because it has a hot, a negative, so plus 3x is less than 4x. We add it here and also before we subtract a 4, so it will die naturally. So 10 is less than 7x minus 4. 4 has a negative, so we add plus 4 on both sides. That's now minus 4 plus 4. That right away gives us 14 is less than 7x. Out of 7, 2 is less than x, which we can say x is greater than 2. Yeah, I want to give you more. You are clear, and we do an interesting one here, not so?
Yes.
Yeah, number 2. See, number 2. That's part B. That's a plus 1 out of 2 minus a plus 3. That's minus 3 out of 4 is less or equal to n plus 2 out of 3. So how do we approach a fraction? We first hot. Let me hear. How do we approach a fraction? Yes.
I'm just thinking.
You're thinking. Think and we see.
We first find the LCM.
We first find the LCM. So LCM of 2, 3, and 4 is what?
12.
I think if you are not sure, you must find it in your rough work, not so? That will be 12. So I will multiply 12 here, and there. Now when you are handling two things, you must introduce the brackets. So it will be 12 into n plus 1 out of 2 minus 12 into n minus 3 out of 4 is less or equal to 12 into n plus 2 out of 3. Brackets help in many things, especially in opening brackets to handle signs. So by 2, 6, by 4, 3, by 3, by that 4. So this will open into this 6 plus that. You've already opened. Okay. That's equal to 4 into n plus 2. So this is 6n plus 1, not so?
6.
That's right, 6. Then here, 3n
Plus negative.
y plus negative times. That means a student should be very keen. Does it mean so? So that will be plus 9 is less or equal to 4n plus 8. So we collect the who. So I have 6n.
Minus 3.
Why not plus 3n?
Because 3n is currently negative.
Because the whole of 3n carries a what? A negative. Then plus 6 plus 9. So I got 4n plus who? 8. 3n plus who?
15.
6 plus 9 is?
15.
Somebody refused the mental math, not so? Why? Collect like terms again, not so?
Yes.
3n, this is a positive value, so we do what?
Subtract.
Minus it, plus 15, less or equal to 4n minus 4n plus 8. So, negative n, that is 3 minus 4. Then plus 15 minus 15 less or equal to 8 minus Why did the entire say 15 minus 8, but 8 minus 15 is the correct one? Why?
Because the positive comes first in 14.
Because it found the 8 on its side. So you cannot go and command in somebody's house, not so? So that gives us negative n less or equal to 7.
Yes.
Like that.
Negative 7.
Wonderful. So we divide through by negative 1, not so?
Yes.
And when you try to divide, the sign does what? Changes. So you receive n is what? Greater or equal to 7. Yeah, the teacher has one more left. Are you ready to handle yours?
Yes.
Me, I'm handling part C. Not so?
Yes.
Okay. That is 3 is greater or equal to 7x minus 1 out of 2 is greater or equal to 1. Now I want to emphasize the concept of two inequalities here. See? When there are two inequalities, you make sure you remove everything from x. See? You remove everything from x must remain as x or 1x. So how will I remove 2 first here? Since the denominators are LCM, I think you have found it already, haven't you?
Yes.
What is the LCM?
2.
So multiply everywhere by 2.
Yes.
2. That's 2 times 3 out of that. Greater or equal to 2 into. Oh, that would sound meaningful to have like this.
Yes.
So that would be more meaningful to use brackets as we agreed before, didn't we? So what do you get? This goes, not so?
Yes.
6 is greater or equal to 7x minus 1 greater or equal to 2. So again, remove 1 from there. 1 is a po. Add it on both. So 6 plus 1 greater or equal to 7x minus 1 plus 1 greater or equal to 2 plus 1. So this will die naturally. That's 7 greater or equal to 7x greater or equal to 3. Remove 7 by how?
Divide both sides.
Divide both sides by 7, 7, 7, 7, 7, 7. So 1 is greater or equal to x greater or equal to. Couldn't somebody say this is? You've already found the other. That's what? 2 whole number. Ah no, you are wrong. Aren't you wrong? Aren't you wrong? Oh, you are correct.
It just makes sense. So many people are reversing, they're saying you should start from the right. Like,
See, now, you see, for double inequalities, listen, for single, it is always good to write the unknown on the what? On the left. The unknown should be on the left. See? But for double, there is a reason why the better representation must be less or equal to. We are going to see that on putting it on a number what? Number line. It is more meaningful here. Here it's meaningless on the number line here. So I want for double inequalities, make sure you end with that. For For single inequalities, the unknown should be on the what? See? Oh, so there are about 4 numbers for you.
Excuse me.
Yes.
What if the unknown was at the right side and not in the middle?
There is no problem. But remember that we agreed in algebra that better say 2x minus 1 than you saying negative 1 plus 2 what? You see, math is beauty. You should know that. Math is beauty. Yes, you guys would like to be what? To be that, not so? But math is beauty. So represent in a way that is more attractive to the examiner. So we are not saying you are wrong, no. But your work would be more nice looking to the examiner in this format than the other what? That's exactly. So, okay, let me put here some 4 for you. Are you ready? See? So, you are very, very ready. So, who is going to be number 1? Should we follow the order? Then I will give you the 5th one. You must discuss it in a group, not so? So yeah. The first student will help us here. And that is, we are calling it part what? Part C. Yeah. Let me have it here. D. Part D. Yes. Oh, that's right. That's right. Then part E. So that's 5 minus 4x greater or equal to negative x plus 8 plus 8. So plus 8. Yeah. Then I have negative 6 is less or equal to 2x minus 4 less or equal to 2. Yeah, that's exactly. Now there will be 3. Then the one who will miss, we shall give her or he or so we shall give that candidate chance. Yeah, that's negative 2 less or equal to 5x minus 3x out of 4 less than or equal to 1. Which candidate will take on this responsibility? Yeah, that's 5 minus out of 4. Okay, there are those. Let me have starting candidate here. Starting student of senior 2. Yes, hurry up. Just 1.5 minutes per person.
Minus 4x is greater or equal to negative x plus 8. So we have 5 and positive 8. So since this is a digit without any letter, we shall have to bring it this side first. So 5 plus, no, since it's a positive this side it will be a negative, minus 8 minus 4x is greater or equal to negative x plus 8 minus 8. So, and since this side it's negative x, we shall have, and this side it's positive, negative 4x, we shall have to take it this side. So 5 minus 8 minus 4x plus 4x is greater or equal to negative x plus 4x. Since this side it was a negative, and remember these ones were cancelled and these ones as well were cancelled. So 5 minus 8 is greater or equal to negative x plus 4x. So 5 minus 8 is negative 3. Is greater or equal to, it is positive 3x. So we shall have to make x the subject by dividing both sides by 3. So here it's negative 1 is greater or equal to x. But then we can still say x is less or equal to negative 1.
Wait a little. Are you doubting her? Can you direct it to her or me?
Not on hers. So use double inequality.
Yes.
If, let me say, you're dividing one side when it's a negative and the other side it's a positive, do you change both the sides?
There is no way it will happen as you are saying.
Okay, like since when you're dividing a negative,
Yes.
the sign has to change, right? Now let me say on the first side, this side you're dividing a negative, and this side you're not. Do you change both the signs?
Now, your question, like if you had negatives less than negative 2 less than 4. Is it what you're asking?
Yeah.
If I'm going to divide by,
No.
of course you are going to divide by negative 2.
How much is your positive?
Ask the question
The
properly.
question is, let me say I have negative 1 on this side, then in the middle I have negative 2x, then this side I have 2.
Isn't this what you're talking about?
Yeah.
If you divide, will negative to divide only one place? Nope, it will divide everywhere, so the sign will change.
But what if negative 2 is a positive?
If it is a positive,
Yeah.
it won't change because this is the determining term, not this.
Okay.
So, okay.
The question is negative 6 is less than or equal to negative 2x minus 4 is less than or equal to 2. So here we have to leave x when it's alone. We don't have to leave it with these known numbers, so it's going to be, we are going to remove this 4 from here, so it will be negative 6 plus 4 is less than or equal to 2x minus 4 plus 4 is less than or equal to 2 plus 4. Negative 6 plus 4 is negative 2 is less than or equal to 2x, because this one they cancel, so it will be 6 on this side. So we will divide all sides by 2. By 2, 1 by 2, 1 by 2. Okay. So we get negative 1.
Yeah, wonderful work from patience. Wonderful. Yeah. The next student. That's Martini hot.
Martini
Milli.
Here we are going to find the LCM, and as you know, the LCM of 2 and 4 is 4.
Say it again.
We are going to find the LCM, and LCM of 2 and 4 is 4. Exactly. So we are going to multiply. We are going to use the LCM, which is 4, to multiply all the figures. -2. We shall put them in the brackets. 3/1. Also times 4. Here we shall multiply 4 times -2, which will give us -8. There it will be 20. 12x. No. Since here it is a fund, here so there is a 4, we shall divide them. So here it will be 5 minus 3x. Here also they will go, which will give us 2. -8. Here we shall do like this, 8. We can take this 5 this side, and 5 plus 5 minus 3x, 2 plus 5. These ones will cancel. 3x goes to 7 plus 8. Here -3x goes to 7 plus.
You missed a step.
Wait, what?
You missed a step. You're supposed to add 5 on all sides. On 8 as well, -8.
It's -8 plus 5.
Say it again.
-8.
Positive one.
It is a positive.
So you have to subtract. Even there, not subtract.
Here.
Could I have one person sharing with her where she is there? You can stay, Mire.
Yeah.
You can stay there. You share with her. Yes. Yes, Grace, share with her here. Mire, stand here. You share with her. Stand here. Stand this way.
Okay, we found the LCM, and the LCM of 4, 2, and 1, the denominator of this number without a fraction, is 4. So she multiplied it, and after multiplying, here she got -8. Then here she remained with 5 minus 3x. Then here she got 2, and that's right. Then here,
And that's right. Eh?
yeah. Since this is -3x, so you'll have to, this 5 is a positive.
Say it again.
This 5 is a positive. So meaning you'll have to subtract it on all sides. So meaning it will be -8 minus 5, then 5 minus 5, yeah, minus 3x is less than or equal to 2 minus 5. So -8 minus 5
they are both negative, so it will be negative 13.
No.
So should I join in the third person?
No, teacher, I'm sure.
You are confident
Yeah.
that her answer is wrong? Okay.
It's negative 13 because these two are both negatives. So is less than or equal to negative 3x is less than or equal to 2 minus 5, it's negative 3 because the negative is greater than the positive. So we shall have to divide all sides by negative 3. Since we are going to divide with a negative, the signs will have to change. So it will be negative 13 is greater or equal to negative 3x so the negative and negative 3, then here I shall remain with 1. So the negative and the negative, so it will be 13 out of 3 is greater or equal to x greater or equal to 1.
So,
I have a question.
yes,
Is it possible to change that into an extraction since that there is?
it is possible. Thank you, Mira. I think you've seen that.
Yes, teacher.
Yeah, that's wonderful. But you can reverse that sign. Yes?
If on this double inequality, if the determinant is a negative, is that going to change the sign?
Exactly. If the determinant is a negative.
On both sides?
No. This value only should be determining. If it's positive, nothing changes. If it's negative, it will affect everywhere. So let me discuss now the number line representing inequalities on the number line and solution sets. Solution sets. I hope that material is very, very clear. That means representing what inequalities on the number line. Number line. See, now you should note that inequalities refer to a range of values. Did you hear that? Inequalities, they refer to a range of values. Like when I say x is greater than 2 in English, it would simply mean, like if I said, give me the number of mangoes which are greater than 2. That means you'll give me maybe 3, or you'll give me maybe 4. etc. You can give me even up to 1 million if you have. See? Yeah. Now you should notice that that means inequalities speak about many values. So on the number line, when we are representing those values, a note that inequality gives what? Refer to what? A range of values. Not so? Sure. They refer to a range of values. Now listen, that on the number line, symbols greater or less are not inclusive. Are not what? E.g., x is greater than 2 means we start from what? We start from who? 3. Now look here that on the number line we shall use an unshaded circle. We now use unshaded hot circle like this to mean that this 2 is not equal. But when we speak of symbols of greater or equal to or less or equal to, that means, like if I said give me 2 or greater than 2, you can even start from 2. So symbols such as this mean the values are equal, are inclusive. So we use a shaded circle. Now examples to make the work more meaningful. Represent the following. Represent who? The following inequalities on a number. I want you to be very, very attentive. So what does it mean? It means that the teacher is going to do up to 6 questions or more. See? Or more to explain the meaning. To explain the meaning. So, oh, I hope you are okay, aren't you? So, now I want to do them from here. Represent them on the number. We start with x is greater or equal to -1. What does that mean on the number line? So, number line, that means you can put a few values. I hope you recall a number line has negative sign. It represents integers. So, where is -1? This here, not so? Is it inclusive?
It is.
So we shade. But where are we pointing?
To the greater than.
To the greater. So point up to anywhere. Now, from there we can get what we call a solution what? Set. You see? X is such that x is equal to what? Okay, let me remove many symbols for you to avoid confusion. X will now be what? What? That means -1 going 0, 1, 2, etc. Clear? That's clear. X less than 2. That would mean is 2 inclusive?
No.
That means what does that mean to your head? I start from, that means I will put it to, but do not shade it. So I'm pointing still that way. You agree?
Yes.
What is the solution set?
1.
Yes. X is giving us
1.
I start from 1, 0,
-1,
etc. etc. Now I want to put examples that involve two inequalities. Oh, that's right. That's right. That's right. Now, when we say -1 less than x less or equal to 5, you see that also. Now listen. The inequality for less. Did you hear that? The inequality for less is what shows a range between two values. That means when you have greater, you have to change it to, that's by agreement. See? Now what does that mean? So 0, -1, -2, 1, 2, 3, 4, 5, 6. That's all. So 5 is inclusive, but 1 is not. You see? So I go at 1, I don't shade it. I go at 5, I shade it. And it will be from here to there. See? What is the solution say it?
x is equal to 0, 1,
X equal to 0,
1,
0,
5, 1, 2, 3,
1, 2, 3, 4, and 5. Did you cheat?
No.
Patience, why are you nodding the head in disagreement? Why? Who can explain her issue? She's nodding the head about this. She doubts.
No.
You don't doubt? You don't doubt it? What this? What are you suggesting?
If -1 is less than x and 5 is less than or equal to x.
What is the meaning in the head? You are trying to figure out. Let us interpret it also. Look here. -1 is less than what?
X.
What does it mean? X is greater than?
-1.
See? So which values are these?
0, 1, 2, 3.
1, 2, 3. It is not so. Now we can list many. 4, 5, 6, etc. Now look here. Now I interpret this part. That's x is less or equal to? What are those?
5 is greater than.
Which values are these? 5. Look here. You are pointing that way. So from 5 going that way. 4, 3. Now, see, listen. It is not so. Now, when these two inequalities are combined, it means we've got their intersection. When we put inequalities together, we have got the common elements between the. Therefore, which ones are they? See? 5 is there. Not so? So, see? You asking again? Which one? This one. Because it's not, did you see? It's not inclusive. So, yeah. So, Grace, you pick those things. That's right. That's right. That's right. Now, let me put for you two numbers here. That's wonderful. That's part D. X is greater than 2 and D. Now, I want to put a note somewhere here that the conjunction, so there are some conjunctions here we use sometimes, the conjunction and means hot, intersection means common elements. See? Whereas the conjunction, which conjunction is that? The conjunction O. This one means union. U. Oh, the word intersection means common element, see? And the word union means all. See? So, all. Yeah. So, all. So, X is that, and X, you see, less than 7. Oh, now you see that. Now you see that we can make it this. You see? By organizing. So, a student can arrange this. You say I have this, so I can make it. That can be 2 is less than what? And X less than 7. So I remove this part. So, and it becomes this. That means, but on the number line, of course, this one, because some candidate, now you should understand inequalities themselves. Now on the number line, how simple are these things? Do you also think so, like I'm thinking? How simple are these things? Now from 2 onwards, but 2 is not inclusive. Do you see where I'm going? Yes. Then from 7 what? Which region do the lines intersect through? The region where the 2 lines pass each other. So in short, when I have this and this, I remove all this and put here 1 line. See? It means intersection. They all pass here. They all pass. So this is not the final representation. This is just a what? I'm using it for explanation reasons, but what you should answer is this, is this. So that means I go at 2 and I go at 7 and I join them this way. That's the answer for this. But you see, but it is easy to see it by this. This is the same thing as this. In fact, I would have said X is greater than -1 and you see this is the same as that. You see, but this is just split up, but it is this, because I would say this 2 is this by just removing this and 2 less X less 7. So oh, that I'm discussing more numbers, you see. So understand them in depth, see, in depth. So yeah, I'm discussing more. Yeah, can we go? We still go, not so? We go. Sorry. We go. Yeah, teacher put more. Yes, let me put more. Given that, that's example what? That's part what?
3.
Okay, example 3. Given that A is equal to X negative 2 less or equal to X less or equal to 4, and B is equal to X. Oh, sorry, this is 1. That's 1. 0 less or equal to X. So now less or equal to 5. Represent a intersection B on the number line. On the number line. Guidance of what to do, I also don't know. Can guide the teacher who is ignorant. And state elements of a intersection. But who can guide the teacher? So, who can guide the teacher? Oh, then I continue with my work. Yes, patience, you want to guide me? Do so. Do so. Do so. What should I do?
So you have to first do a number line.
I have to first do a number line for for who?
For A.
For A.
Yes, okay.
A, that means I must interpret H. So, A is running from what? You are okay with A? Is it this? You're just thinking. See?
We mark our negative 2.
We make our negative 2.
So if it says negative 2 is less or equal to X, so it means it's included.
It is inclusive.
Yeah. So we put our arrow.
Up to who?
1.
1. Also,
Yeah.
like that.
Yes.
That's all.
Then we draw our number line.
This is A.
Yes.
Then
Then we draw our one for B.
for B. For B. For B. For B. So, she said we draw for who? What can I say now there?
Then it says 0 is less than X.
0.
So it means 0 is not included.
Inclusive.
And it says X is less or equal to 5.
5.
It's inclusive.
Inclusive. So this one.
So they say it represents A and B on the number line and state elements. So we have to see where those two
They say represent their intersection. See?
intersection will be.
What is that?
So we have to see where those two lines intersected from.
Yes. Where they did what?
Intersected.
Okay, let me hear from you. Where did they intersect from? So,
For me, I think you have to group both with A and B.
You first put and.
on that same one.
Yeah, so that you can find the numbers of the intersection.
So I can find the intersection digits. She had a suggestion.
You first write like negative 2 is less or equal to X, less or equal to 1,
And 5.
and 0. Then
But, okay, but you guided here. Why did you state these elements first? How so? What are as elements?
Negative 2, negative 1, 0, 1.
1. What are these elements here?
1, 2, 3, 4, and 5.
What are the common elements?
1,
1. And only, not so? So, that means, will I have 1 being on the number line alone? 1 alone. So, that means I'll only shade it.
But teacher, what if you use that method of it can still give you?
It can still give 1 as the common. But, okay. It can, because that means I will shade. Where will I shade? You wanted me to shade at 5. To shade this first.
Yes.
Where do I shade? Negative 2.
And then
Let me hope the number I captured it the way it should be. Yeah. And I shade 1 here.
no, positive 1 is already
It's already shaded.
Then you shade 0 and 5.
I remember this is already A.
Yes.
Then at 5 I shade.
0 and 5. 5 on shade and circle.
I circle 0. So here, where are they common?
1.
That means they are only having.
Because you don't count the zeros.
We don't count the 0, but you see that it is from here to here that. But 0 is uninclusive, so the actual number line would be. Want it to be from 0 not inclusive to 1 inclusive? What do you suggest? See, are you suggesting that?
Yes.
That is the actual intersection after working out. You agree?
Yes.
You agree that it's this? Then the element A intersection B is only? Not so. Which has 1 element. So either, but I would advise we take 1. We take 1 for purpose. The first one is to help you. Of course, you can't see without these workings, not so? So show this, then show this. Fine. Thank you very much. It was a bit cumbersome, wasn't it? So I'm doing more. So yes, yeah. So are you set? We continue? And that's exactly. Solve each and represent on the number line. Solve each and represent on the number line. Oh, that means you'll help me here, won't you? I'm doing only 2. That's 15 minus 40 is greater or equal to 5. Okay. How is this? How am I going to solve this? I will take the other side by subtraction. So, why not addition?
Because 15 is a positive.
15 is a positive. This is for negative 4, not so? So we get negative 40 greater than or equal to what?
10.
10. Negative 10. See? Then that will give us what?
Negative 40 is greater.
Negative 40. I hope I captured the number right here. Nope. I'm trying to dodge.
20.
That would give us what?
20.
This will give us that's negative 20. So 40, not so?
Yes.
Out of 4, out of that, t is less or equal to?
5.
5. So on the number line, is 5 inclusive?
Yes.
So you can state the solution set also, can't you?
Yes, I can.
So what is T's values?
5,
5, 4,
3, 2, 1.
etc.
Yeah.
Oh. Allow me to solve to solve one more. Not so? How many people are ready to also solve some? This question says use a number line to find the integral values of. Use a number line to find the integral values. The word integral means non-fractional or decimal answers. Did you hear that? That means you don't have to indicate the 2.5 integral values, non-fractional or decimal. See, they should be non-fractional or non-decimals. See, of the sets. Oh, that's 3x is greater than 2x plus 5 intersection. Again, help me, you don't leave things for me alone. I might crash, not so? That 2 minus x. So be very, very ready to help me, because together we stand, but divided we. So, yeah, that's right. Could you guide me on the attempt for this? Then I will put it on the number line.
Yes.
What will I do?
First, solve for x.
I would first solve for x. How?
In the first bracket, we subtract 2x.
That means I handle bracket by bracket.
Yes.
So I will say 3x minus 2x greater than 2x minus 2x plus 5. So x is greater than who? 5. So I solve next bracket, 3x less than 32 minus x. So 3x plus x less than 32. 4x less than 32. Out of 4, x is less than 8. See? Then I combine them. Oh, what did it say? Intercept. So it will be x greater than 5, intersection x less than 8. Who can help me and combine? See? I know the other ways of handling it on the number line. You can handle this and see values and handle that, then intersect them. But I want somebody who can merge this to be one expression and put it on the number line. Yes, Grace is warming up ready. We give her a chance. It would be?
5 is less than x. 5 is less than x.
5 is less. Oh, what have I written? Can you imagine? 5 is less than x.
X is less than 8.
Then intersection x is less than?
No, not I just put less than 8.
Less than 8.
Yes.
Wonderful. So this is easy, not so?
Yeah.
So So 6, 7, 8, and 9. So we shall have from who? 5 to 8. Are they inclusive? No. What is the solution set?
6, 7.
6, 7. Yeah. Okay, then warm up to do yours now. The teacher has done it through that section. So,
Please add on the definition of integral value.
Integral value, the word integral simply means the values which are not fractions or decimal, because a decimal is a fraction, like 1 out of 2 is 0.5. So don't state any decimal number. Don't say 6.5 or 6 point what. So how many are ready? Yeah. Okay, now let me point you to this, and people are ready to solve and put on the what? Okay. Yeah. Okay, the first student, I think you're ready. Solve and represent the solution on the number line. Solve and represent the solution on the number line. That's A. Then let's equal to 20. So I got 15. How many are ready? Yeah. Okay, that is direct here. No need to solve. Then x less than 6. Intersection -3 less or equal to x less or equal to 4. Okay, could I have that student? 2 students. Yeah.
Okay, we are solving and representing the solution on the number line. We shall first solve. 10 is less than or equal to 20 minus 5y less than or equal to 15. So we shall have to subtract 20 on both sides, on all sides. Why we are subtracting, it's because the 20 is a positive, so it will be 10 minus 20 less than or equal to 20 minus 20 minus 5y less than or equal to 15 minus 20. 10 minus 20 gives us negative 10 less than or equal to negative 5y less than or equal to positive 5. it will be negative 5. 15 minus 20, negative 5. So since we are going to subtract all sides, divide all sides by a negative, the signs will be affected. So it will be 10 out of negative 5 greater or equal to negative 5 y out of negative 5 greater or equal to negative 5 out of negative 5. This will give us 1. This will give us 2. So 2 is greater or equal to y, and y is greater or equal to 1. So with our number line down here, so we shall have to first look for the 2. The 2 will be inclusive because it's greater or equal to. And then 1 greater or equal to. So the solution set y is equal to 1 and 2.
Yeah, thank you, Grace, very, very much. Yeah, but I wanted very much to reverse this, because ideally to lie between 2, if y is between 1 and 2, the representation is with less signs. It's okay, thank you very much. Yeah, are you coming?
Alright, I'm going to first deal with this left side of the expression, which is 2 is less than x, which is less than 6. I think it's already simplified, so the intersection part is negative 3. So, we are going to first deal with this part. So 2 is less than x, so it will be like 6 is greater than x and is greater than 2. So 6 is not included. Then we have to, oh my god, let me just use this upper and for less. 2 is less than x is good. Then just redraw another number now. 2 is less than x, so it means it goes, and then x is less than 6, so it means it goes still. So we go for this one. Negative 3 is less or equal to x, so it means this one is inclusive. And then x is less or equal to 4. So here, since the list is countless, the solution set will be x will be 5, 4, 3, 2, 1. It is to there. No, let's put it over. Let me just leave. It is C. Then this one, it is -3, -2, -1, 0, 1, 2, 3, and 4. Then they are asking for the intersection. And we look here and here, we can see that 4 is on the list, 3 is on the list, 1 is on the list, 0 is on the list, -1, and -3. -2, -3, they are all on the list, and so the intersection will be it will be 1, 0, 1, -3, -2, -1, 0, 1, 3, 4. That's what I think.
Okay, thank you for that wonderful presentation. You have a different view?
Teacher, for the first one, 2 is less than x and x is less than 6. And I think it is 3, 4, and 5.
3, 4, 5.
Yes.
Oh, you are giving us another approach, rather. She's suggesting that we can state these elements, then state those. That means, okay, let's try to see if we conclude with hand, see if we write the same. Here you are saying 2 is not inclusive, not so?
Yes.
Even this. So you have, each number line will have
3, 4, 5.
Then you are looking for the intersection with what? From 3 to what?
From 4 to 4.
That's -3?
-2, -1, 0, 1,
2, 3.
4.
What's common?
3 and 4.
3. These are common.
5 is not.
This is, so this is not. Therefore,
The intersection is 3.
the intersection would just be 3 to 4.
Yeah.
Of course, yes.
According
according to the way I'm seeing, they said 2 is less than the x, and the number
Now,
is less than
I also wanted to really explain this thing here, because I'm saying that there is a certain mismatch. See, now we have said the meaning of 2x. You see, when the meaning is that x is between 2 and 6, but 6 and 2 are not inclusive. This means x is between 3 and 4. And we have said that the correct meaning of to be between is not, of course it is better this way, but this means the same. So to be between, whether they have used this or less, it simply means you are between those. Yes, that means take that when x is placed between two values, then you just know x is between those two values, and you check whether it is inclusive or not inclusive. So, but I told you that the better representation is with less signs than with greater what? Signs. Though they mean the same, but I told you math is beauty. See? Did you hear that? Math is beautiful. Yeah. So, now I think you've understood fully here. You can use the number line to detect the elements here and use the number to detect the elements here. Then you can join them. But remember that they want a use of number lines to answer the question. See? So, you do simply pick on this. See? That means you'd pick on 2 less than x less than 6, put its number line, then list its solution set. Then also pick on this, put its number line, list the solution set, check the common, and put a final number line for both. You understand? Did you understand that?
Yes.
Then you put for both. See? That here would be 0, 1, 2, 3, 4, 5, 6, and what? 7. So you would pick from 2 to 6, non-inclusive both. So x is 3, 4, and what? 5. Agree? Agree? So then this one is negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. 3. So now you would shade here and get that. So you'd have this negative 2, negative 1, 0, 1, 2, 3, and what? Now you check who is common. It is 3 and 4. And 4. And 4. So now put that, see, put that. Grace, are you okay? Yes. And you see the things or you do not see them? So they are both inclusive, and that's the final answer that they want. So they say the solve using a number. Oh, now class, we are shifting to another section called the solving into unknowns, and there we need the graph. I hope you came along with the graph papers. Yes. Just shortly and we start. Not so? Shortly and we resume on.